In today's class, so we are going to discuss about our next topic, which is normal forms of context-free grammars. So what is this normal forms of? So normal forms in the sense, so let us observe that. Let me tell you one small example. One small example, let me give one small example so that you can understand. So what is the normal form is. So let us observe that I have a grammar like this. S directs to small a, capital B, or capital A, small capital B, and C. Capital A, capital B, and C. Now what I am doing here is I am going to rewrite the same grammar. I am going to rewrite the grammar in some other way, something like this. What is that way? You can see here, I am going to call it this small a like XA, capital B, or capital A, capital A, Y, capital A, Y. So where XA refers to small a and Y refers to BC. Y refers to BC. Now please observe, this is our input grammar and this is the grammar which has been rewritten. Means I am writing this grammar in some other way, in some other form. Okay. Now please observe, when I substitute this XA production here, then what I will get? I will get this part, AB part. In the same manner, when I substitute or when I introduce the Y production, which is BC, in the place of Y, again I will get a production which is capital ABC. In the sense, now what I want to tell you here is, so we are going to have our grammar in some form, but now what we are trying to do is we are trying to rewrite our grammar in some standard form, in some standard form. Now, when we are writing your grammar in some standard form, we need to make sure that the originality of the grammar should not be affected. What do you mean by originality of the grammar? In the sense, so after you rewrite your grammar something like this in the form of three different productions. Now, when you try to merge all these productions, then automatically what should happen is you should get your original grammar. Now, just check whether we are going to get our original grammar or not. You can see here we have a production capital S and we have written XA. What is this XA is? XA is nothing but small a. XA is nothing but small a. So small a, capital B, or we have capital A, and what is this Y is? Y is nothing but capital BC. Y is nothing but capital BC. Now please observe, now by rewriting our grammar in terms of three different productions, again we are able to get our original grammar or not. Please check whether we got our original grammar or not. Yes, we are getting our original grammar. Now this is what we call normal forms. Okay, please try to understand. Normal forms is nothing but, so we are going to have grammar in different ways. Now whatever the grammar we have, now we are going to rewrite our grammar in some standard format. Okay, now what is that standard format? Why we should write? In the sense, the here the main thing which you need to remember is, when we are going to convert our grammar into the normal forms, we need to make sure that the originality of the grammar should not be affected. Just now I told you that we are going to write our grammar into some standard formats. Now what is that standard format? That standard format will be dependent on the kind of normal form what you are going to use. Okay. Now for example, let us observe that we have two types of normal forms. We have two types of normal forms. So what are the two types of normal forms? The first one is a CNF form. We also call Chomsky normal form. So we call Chomsky normal form. So also called as CNF form. Then the second one is gray-back normal form. The second one is gray-back normal form, also called GNF. Now here you need to understand when can we say some grammar is available in Chomsky normal form and some grammar is available in Grayback normal form. Now please observe a grammar G is said to be available in the Chomsky normal form or in a CNF form if and only if, listen carefully, if and only if all its productions are in this form: A derives to BC or A derives to A. A derives to A. And you know where A comma B comma C, A comma B comma C are uppercase letters, in the sense all these are variables. And small a should belong to terminal. Small a should belong to terminal. It should be a terminal. Understand? In the sense, when I can say my grammar is available in Chomsky normal form if and only if all my productions are available in this form. What is that form? A derives to BC. In the sense, on the right hand side of any production, max of two variables should be available. Max of two variables should be available, or there should exist at most one terminal on the right hand side of the production. Then we can say that so all my grammar is present in the Chomsky normal form. And let us go ahead and see what is this Grayback normal form is. Now I can say that a grammar G is said to be in a Grayback normal form if and only if all its productions are available in this form. A derives to AB star, where where capital A belongs to variable. Capital A belongs to variable, capital B, and small a belongs to what? Small a belongs to what? Small a belongs to terminal. Small a belongs to terminal. In the sense, please observe, on the right hand side, I need to have either a terminal followed by V star, in the sense what? V in the sense set of variables. So on the right hand side of the production, I need to have a terminal followed by any number of variables, or no variable at all. No variable at all. No variable in the sense, the meaning is only one terminal will be available. Now, if my grammar productions are available in this form, then I can say that my grammar is available in the GNF form. Understand? So please make sure that, so we can say that our grammar is present in either Chomsky normal form or in a Grayback normal form. So depending on how we are going to rewrite our productions. So if we rewrite our productions in this form, like A derives to BC in the sense, on the right hand side, we need to have a max of only two variables, or you need to have only one terminal. If we rewrite our productions like this, then we can say that our grammar is present in the Chomsky normal form. Suppose if we have a productions like this, where we have terminal followed by any number of variables, terminal followed by any number of variables, or terminal, only terminal, then we can say that so my grammar is present in the Grayback normal form. Okay. Now this is what we have, some simple introduction, some brief introduction about the normal forms. You can see here, just now I told you we will be having two normal forms. One is a CNF and the second one is a GNF. Just now I told you that we are going to have our grammar is present in the CNF form if and only if we follow this two production rules. Okay. And please remember that epsilon is not going to be part of either CNF or a GNF. Please remember that epsilon should not belong to either CNF or a GNF. Suppose think that if you want epsilon production to be available inside your grammar in the sense, then you need to make sure that epsilon production variable, you should not appear on the right hand side. It should not appear on the right hand side of any production. It should not appear on the right hand side of any production. Okay, that is what we need to make sure. Okay, now this is the algorithm that we are going to follow in order to convert any grammar into the Chomsky normal form. I will explain about this algorithm later, but before that, let us take one small example and try to convert our grammar into Chomsky normal form. Okay, so let us take, we have a grammar like this: S derives to small a capital A, small b capital B. And the second one we have capital A derives to small a capital A or A. And B derives to small b capital B or B. Now what we have to do now? We need to convert the below grammar, convert the below grammar into CNF, Chomsky normal form. Now you know that what is the Chomsky normal form says? The Chomsky normal form says that all our predictions should be like this: A or BC or A derives to A. A derives to A. In the sense, on the right hand side of any variable, we need to have, the right hand side for any prediction should have max of two variables, or we can have a max of one terminal. Now just check out of all these predictions. So totally we have one prediction, two, three, four, five predictions are there. Out of all these predictions, so how many predictions are there which are already in the CNF? Already in the CNF. Now please make sure, see, observe here, we have four symbols available. That too, you can see here, we have a terminal followed by variable, terminal followed by variable. So this grammar is not in the CNF. It is not in CNF. Now we need to convert this production into CNF. Then you please observe, here we have max of two symbols available. Max of two are available. But the problem here is, so we need to have two symbols where these two symbols must be variables. But here what is happening? We have a terminal and a variable. Now it is not following this property. So hence we can say that this is also not in CNF. This is also not in CNF. But what about this production? Let us write the next production. A derives to small a. Now is it available in this form or not? Is it available in this form or not? Yes. So it is in CNF form. It is in CNF form. Now let us go over here and let us check what about the B production. B derives to small b capital B. But what we want on the right hand side of any production, we want two variables or we want one terminal. But here what is happening? We have a terminal followed by a variable. So now we can say that it is also not in CNF. It is also not in CNF. Then what about the last one? Is it available in this form or not? So we have a variable which is producing one terminal. You can see here b derives to small b. Yes, it is available in our required form. So it is in Chomsky normal form. So finally, from the given input grammar, straight away we have identified that we have two predictions which are available in CNF form, which are available in the CNF form. Okay. Now let me take one small table so that it becomes very easy for us. Okay. So first we take this one, this prediction. So first we'll take this prediction. Control C. So here I am going to write prediction, grammar prediction, and here it's a corresponding Chomsky normal form. We are going to write it's a corresponding Chomsky normal form. and this is our second production. So this is our sorry. So this is our second production, and this is a third one. So this third one is already available in CNF. So I am writing straight away here itself. And this one is not available. So we need to convert it. We need to convert it. Okay. Then last one. This is also available in CNF. So this is also available in CNF. So straight away I am going to write to my result. Okay. Now see, before going to discuss about the first one, let us look into the easiest one. Easiest one. What is that easiest one is? Please observe. Let us take the second production. Let us take the second production. What is this production? A derives to small a capital A. But what we actually want, A derives to BC form. BC form. BC in the sense we need to have this small a in the place of small a. We need to have a variable, and this second symbol is already a variable. Now what we have to do is we need to go for making use of some mechanism where this terminal can be converted into something like what we call a variable. Now what actually I am doing, that is the reason why now I am going to introduce a new variable called XA. Please observe. Now I am going to replace this variable, I mean symbol or terminal small a with a new variable called XA. And what about this capital A? This capital A is already a variable. Now you please observe over here. Now we got two variables or not. XA is a variable and the capital A is a variable. Now did we got a max of two variables on the right hand side of the production or not? Yes, we got it. So now we can say that it is also available in a CNF form. But what about this XA is? Now we need to confirm. What is this XA is? XA is nothing but small a. XA is nothing but small a. Now please observe. Now when I again remove this XA and substitute this XA with the small a, again we will get back the same production called small a capital A. Understand? So this is how we are going to rewrite our grammar in such a way that again we will get the same productions in our required form. Okay. Now we will apply the same for this one also. B derives to small b capital B. Now in the place of this variable, I mean this terminal b, small b, now I am going to introduce a new variable called xb. I am going to introduce a new variable called xb. xb capital B. xb capital B. Now it is, now this production is in CNF, Chomsky normal form. Now we need to define what is this xb is. Can you please look into this? What is xb now? xb is nothing but small b. xb is nothing but small b. Okay. Now with this, what we have did so far, we have converted the grammar which is not in CNF into the Chomsky normal form. Now have a look at this. How I am saying, on the right hand side of the production, we have max of two variables, and on the right hand side of this production, we have a max of one terminal. And here in this case also, we have max of two variables and we have a max of one term. So like this, what we did, we have converted this production and as well as this production into the Chomsky normal form. But let us go ahead and we'll look into this one, which is very important for us. Now, how do you convert this production into the Chomsky normal form? How do you convert this production into Chomsky normal form? Now, again, we are going to make use of the same procedure. So now, please observe that on the right hand side of the any variables production, max of two variables should be available. Max of two variables should be available. That is the reason why now what I am doing is, first I am going to take this A as a XA. Already we know that XA is there. Please observe, XA derives to small a. Is it there or not? Now that is the reason why what I am doing, I am going to rewrite this S derives to XA capital A small b capital B. XA capital A small b capital B. Okay, and we already know that. See, now we have on the right hand side of this A, what we have four symbols are appearing. Out of these four symbols, first two are variables, then we have a terminal, then we have a variable. Now in this scenario, what I am doing is, now please observe, now what I am doing, S derives to XA, XA. Now, right. Now what I am doing here, as I need to confirm that in this production, there should exist max of two variables. That is the reason why what I am doing. Now in the place of these three, this substring like a capital A, small b, capital B, I am going to replace it with the Z. Please have a look at this. Now, did we got two variables appearing on the right hand side of the production? Capital XA and Z. Now here I need to specify what is this XA is. So here I need to write XA is nothing but small a. XA is nothing but small a. As we are already written XA, so here there is no need for us to write what is XA, and then next we need to specify what is this Z is. Z derives to capital A small b capital B. Z derives to capital A small b and capital B. Now this is what we are going to get. Now, when we look into this Z production, as we want this to be available in CNF, we need to make sure that, so this variable followed by one max of one variable only. But here what is happening? We have a substring called small b and capital B. So that is the reason why now I am calling it like a Z1. So let me take it like subscript. So I am calling it like Z1. So this is also Z1, Z1. And now I am going to write this Z1 as, so Z1 derives to, so let me write Z1 derives to small capital A Z2, Z2. Now I need to specify what is this Z2 is. Let me write here itself, where Z2 is nothing but, see here I am writing Z2 derives to small b, Z2 derives to small b capital B. Z2 derives to small b capital B. But here the problem is, again when you look into Z2 productions over here, again we have a variable followed by something like, I mean terminal followed by a variable. But what we want variable followed by variable. Now that is the reason why what we'll do, we are going to introduce a new variable called xb derives to b, xb derives to b. Now with the help of this xb production, now this z2 can be rewritten as follows. This z2 can be rewritten as follows. In the place of this b, we are going to get xb. So where this xb is nothing but xb derives to what? Small b. Now please observe now. This is what the grammar which we have taken. Now finally what we did here, finally we have converted our grammar into the required form. So what is that form? See, please observe. Let me write down all these things over here. So first and foremost thing which we did is, so we have replaced this small a with xa, small a with xa. Then we have rewritten capital A, small b, capital B with Z1. See here. And again we have written this is capital A, small b and capital B with this one. Okay. Let us check over here. We need to write this production with Z1 derives to. So here we need to write in the place of this production, we need to write Z1 derives to Z1 derives to A Z2. Z1 derives to A Z2. Now please observe Z1 derives to A Z2, where Z2 is small b capital B. And please observe, as Z2 productions are having terminal followed by variable, which is not following the CNF rule. So hence we are going to introduce a new variable xb capital B. Again, we are going to take this xb as like this. Okay. So finally, what we have done? So finally, we have written our Z1 production like Z1 derives to A Z2. Okay. Now, finally, when we convert our entire grammar, the productions which will be available in our CNF form are, let me write the final answer over here. So, grammar, grammar in CNF is, the grammar which is in CNF is, so first we need to start from the start symbol of our grammar. S derives to XAZ1. S derives to XAZ1. Okay. Then we need to specify what is this XAZ1 and all these XAZ1. Now please observe. So XA is derives to small a. And what about Z1 productions? So Z1 productions are like this. So these are the Z1 productions. Z1 derives to these productions. And we need to specify Z2 productions also. Z2 and XB. Z2 and XB. Now have a look at this. So we have Z2 and XB productions also. Okay, so these are the productions so which we are going to get after converting the S productions. Okay, now these are the various productions which will be resulting in after converting our grammar into required normal form. Okay, now if you have any doubt, just substitute all the productions. So finally you will get a production like S derives to small a capital A, small b capital B. Now you can check it out. So just substitute this XP production in Z2, you will get small b capital B. So here you will get small b capital B. Now when you substitute this Z2 small b capital B, here you will get in this place you will get capital A small b capital B. Okay, and here in this place when you substitute or when you replace the XA and Z1 production, what is XA? Small a. Z2 production capital A small b capital B. Now please observe, did we got the same production what we are looking for? Small a capital B small b capital B. Now the same production will be available for us. Okay, just now I told you in the beginning of our discussion that so normal forms in the sense we are actually going to rewrite our grammar in some standard format. So what is that standard format in the sense? So it is up to the form what you are going to use. Like if you are using a Chomsky normal form, there will be a format, and if you are using a Grayback normal form, there will be a format. Okay. Now these are the productions for this yes. Now we need to specify for A productions also. What are the A productions? A productions are A derives to this one. So let us rewrite. These are the A productions. Then we need to specify this one also. So A derives to this one. Next, we need to specify B productions. So specify the all the productions. Control B. I hope this is not A. I hope this is B. B productions. B productions. As already we have xb derives to b, so this is not required for us. This is not required for us. Then finally we can write b derives to b. We can write b derives to b. Okay. Now this is what the grammar which we are going to get after converting them into the corresponding normal form, especially the Chomsky normal form. Understand? Okay. So here we have learned few things like whenever, please listen, whenever the right hand side of the production is having more than two symbols, then what we are doing, we are breaking them into two parts. See here what we did. First we have taken the first symbol as it is, then whatever the symbols are there on the right hand side, remaining symbols are there on the right hand side, we are going to replace it with a new variable. Then again we are going to check, so how many symbols are there. If the length is greater than 2, again we are going to break it into a new string. Okay. Now this is what the procedure which we follow in order to convert our grammar into the given Chomsky normal form. Okay. Now let us go ahead and work it out with one more example so that it becomes very easy for you. It will be very easy for you in understanding the tomorrow's topic, because this is a very simple grammar where we are applying the CNF. But this is not the case what you are going to face in your exams, because when you go for converting your grammar into the CNF form, it is possible that you may have different types of things. Something like epsilon productions will be there, unit productions will be there, and useless symbols will be there. Now, what you have to do before going to use the grammar and convert the grammar into the corresponding CNF form, first of all, you need to simplify the grammar. As part of the simplification, we need to go for removing the null productions. We need to go for removing the unit productions, and we need to go for the removal of useless symbols. So I will discuss about all these steps in the next class, and I will tell you about the first step also in next class. But if you observe, as part of our algorithm, we have finished the fifth step and the sixth step. What is the fifth step? It is saying that replace each production A derives to B1, B2 and so on Bn, where n is greater than 2. In the sense, the length of the right hand side production is greater than 2. In such a case, where you are going to replace it with A with B1 C. See, we are having the first symbol as it is. Whatever the remaining symbols are there, we are going to replace it with the C. Okay, means we are going to make use of a new variable. And what is this C is? C is nothing but B2 to Bn. Now you can see here C means B2 to Bn. And we are going to repeat the same step for all the productions having two or more symbols in the right hand side. Okay. Then the next step is, if the right hand side of the any production is in the form A derives to small a capital B, where A is nothing but what? A is a terminal. In such cases, what we are doing? We are replacing this terminal with a new variable called XA. So here he has taken only X, but it is possible that in our grammar we are going to get more number of such type of symbols. In order to avoid the confusion, what we are doing, we are going to make use of a variable called XA, and we need to specify what is that X production is. So that X production is a small a. Now we need to repeat this procedure for each and every step which is available inside the production. Now, as part of our conversion from given grammar to CNF, we have followed the step 5 and step 6. And I will tell you about the rest of the 4 steps in our next class. Just hold on a second. Let me take one more grammar. If you observe over here, this is our grammar, and these are our productions. As per our previous example, so I'm taking in the form of a table, and we are trying to convert it into the corresponding CNF form. Now, please check straight away any such production is there which is already available in the CNF form. Now, please observe here the first production is capital A, capital B, small a. Now we have more than two symbols. As we have more than two symbols available, so now we can say that this production is not available in the CNF form. Now go for next one. Please observe over here. Here we have three symbols available on the right hand side of the production. So now we can say that it is also not available in the CNF form. Then what about the next production B derives to AC? On the right hand side, we have a max of two symbols and these two symbols are variables. Now we can say that this production is in CNF form. It is in CNF form. So hence it will be added to our CNF list. It will be added to our CNF list. Okay. Then what we have to do, we need to convert this production into the corresponding CNF form. So for that, what we have to do, just now we told you that. So we discussed that whenever we have the symbols, the length of the right hand side is greater than 2. In such cases, what we have to do, we need to split it into parts, partition in such a way that on the right hand side, length will be equivalent to 2. So how I am going to do that? So this A will remain as it is, and in the place of BA, now I am going to introduce a new variable called Z1. You can see here. So S derives to capital A Z1. Capital A Z1. Okay. Now I need to specify what is this Z1 is. I hope you are able to understand. Now what will be Z1 now? Z1 will be nothing but capital B small a. So Z1 will be capital B. Z1 will be capital B small a. Capital B small a. So let me write that capital B small a. Okay. Now if you observe thoroughly the Z1 productions, what we have is a variable followed by 1 minute. Wait a second. Okay, you can see here now the Z1 productions. When we look into the Z1 productions, we have capital B. I mean, two symbols are there, but the problem here is we have a variable followed by a terminal. But as per CNF form, what we should have, we need to have that. So this we need to have only two variables, but we have variable followed by terminal. Now what I am doing here, I am going to make use of a new variable. I am going to introduce a new variable over here. So please observe what I am doing. So this I am going to call it XA. I am going to call it XA. Now what about XA production will be? XA productions will be small a. XA productions will be small a. Now when we look into our resultant grammar over here, resultant grammar in CNF. So first we will get S derives to small a capital Z1. This is our first production. Then we will get Z1 production and the XA production. Z1 production and XA production. Let me write Z1 and XA. And then we need to have the next production capital A derives to small a b. So this production needs to be converted into the corresponding CNF form. So for that what I am doing, already we know that small a, already we have a production. How this small a can be converted into? It can be converted into XA. So we have XA. So capital A derives to XA AB. XA AB. So this XA is already, we know that we have small a. Now what we will do now, so I am going to make use of a new production called XA. XA. Now already we have Z1. Now I am going to call Z2. XA Z2. What is this Z2 will be now? Now you can easily guess what will be this Z2. This Z2 will be this is small ab. Z2 will be small ab. Z2 will be Z2 will be small ab. Now have a look at this. Z2 will be small ab. Okay, but again, if you have a look at this, so again it is not available in our required form. So now what we'll do, we'll try to convert it into the required form. So how I am writing that? So it will be XA because already we have a production, and it will be XB. But this production is not available, so hence we need to specify XB derives to small b. XB derives to small b. Now we need to specify all those productions which are available in the Chomsky normal form. So this production is available in Chomsky normal form where A derives to XA Z2, and Z2 productions are XA XB, and XB productions are B. XA XB and XB productions are B. You can see here. So we will get this production. And finally, this production is already available in Chomsky normal form. So hence we get this required resultant grammar. So this is our grammar which is available in the Chomsky normal form. So if you have any doubts, you can check it over here. You can check it over here. See here on the right hand side of any variable, we have max of two variables. You can see A Z1, two variables, B X A, two variables, and here we have max of one terminal, and here two variables. Here also two variables. Here one terminal. Here two variables. Understand? So like this, what we are doing, we are going to convert our given grammar into the corresponding Chomsky normal form. Okay, so here in today's class, whatever I discussed, I have taken a very simple example. Using the simple example, we have done the conversion from given input grammar to the Chomsky normal form. But in our tomorrow's class, we are going to enter into the actual process where we are going to see to work with a grammar which is having unit projections, epsilon projections, and as well as useless symbols. Whenever you have such type of symbols available in your grammar, how you are going to convert it into the corresponding CNF form. Okay, so which we are going to cover in our tomorrow's class. Okay, so that's it for today's class. So thank you very much for joining today's class.